Hi friends, welcome back. So in the previous session we have seen what is the central ordinate property in the Z transform. So I'm just repeating it. X of Z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. And I told you at z is equal to 1, that is x of 1 is equal to summation n is equal to minus infinity to infinity x of n. This is what we have seen. Okay. Now let's see. And we have seen one example also. Summation n is equal to 0 to infinity n a power n is a by 1 minus a whole square. A by 1 minus a whole square. So based on this, there was a question. Let's say, what is that question? Question number 2. Summation n is equal to 0 to infinity n 1 by 2 whole power n is equal to. Okay. So here from this formula a value is equal to 1 by 2. If a is equal to 1 by 2, then we can substitute directly 1 by 2 by 1 minus 1 by 2 whole square. 1 minus 1 by 2 whole square. Then this is going to be 1 by 1 by 4. So 1 by 2 by 1 by 4. That is nothing but 2. This is the answer you got. Similar to this, let's say, if I ask summation n is equal to 0 to infinity n plus 1 a power n, what it is going to be? So similar to that, we can write summation n is equal to minus infinity to infinity n plus 1 a power n u of n. So this is what we are going to get. So let's call the signal is x of n. Then this is equal to x of 1. X of 1. What is x of 1? Let's say. First, for n plus 1 a power n u of n. What is x of z? Let's call it is x of n. What is x of z? This is nothing but 1 by 1 minus a z inverse whole square. A z inverse whole square. So from this I can say what is x of 1? 1 by 1 minus a whole square. That is the formula we can say. Clear? Take it. Question number 3. Y of n is equal to alpha y of n minus 1 plus beta y of n. Sorry, x of n. If impulse response of the system is, if impulse response of the system h of n satisfy summation n is equal to 0 to infinity h of n is equal to 2, then the relation between alpha and beta is options. Alpha is equal to 1 minus beta by 2. Option B, alpha is equal to 1 plus beta by 2. Option C, alpha is equal to 2 beta. Option D, alpha is equal to minus 2 beta. Okay. Try to understand. They have given some difference relation between y of n and x of n, and they said impulse response is satisfying this condition. Then what is the relation between alpha and beta? That is what we have to see. So let's say, first of all, try to understand this one. Can you calculate what is h of n? Yes, maybe. Or we can say, what is they have given here? Let's see, given. Given. Summation n is equal to 0 to infinity h of n is equal to 2. Now, let's say, in general, every system is a causal system. That means which are existing systems. So, in default, we can assume the system is a causal. Okay. So, if h of n is causal, then we can say summation n is equal to minus infinity to infinity h of n is same as summation n is equal to 0 to infinity, because h of n is causal means it is existing only for positive values of n, which is equal to 2. This is nothing but h of 1. That means if you could find out h of z, in that if z value is equal to 1, that value is equal to 1. So this is what we have to take care. H of 1 is equal to 2. Okay. So first find out the h of z and place z is equal to 1. Then you can get the relation between alpha and beta. So let's say, from this one, y of n is equal to alpha y of n minus 1 plus beta x of n. So what is the Z transform for this? Y of z is equal to alpha y of z into z inverse plus beta x of z. Beta x of z. Bring it this here. If I take y of z common out, 1 minus alpha z inverse is equal to beta x of z. Beta x of z. From this, what is h of z? This is equal to y of z by x of z, which is equal to 1 by 1 minus alpha z inverse. This is what we got. Sorry, beta. Beta is this. This is what we got. And we know h of 1 is equal to 2. So, h of 1. What is h of 1 actually? Beta by 1 minus alpha. This is equal to 2. So, from this we can say beta by 2 is equal to 1 minus alpha. Then alpha bring it here, beta by 2 bring it here. So, alpha is equal to 1 minus beta by 2. So, this is the relation what we got, which is option A. Clear? Question number 4. X of z is equal to 1 by 1 minus 2 z inverse whole square with ROC mod z greater than 2. Then small x of 2 is. This is the question. So x of z is given, ROC is given. Okay. So x of z is given, ROC is mod z greater than 2. So I can directly calculate x of n. So why we have to worry? X of n, this is the formula for n plus 1 a power n u of n, where a is equal to 2 power n u of n. That's it. Direct formula. Then I can directly calculate x of 2. 2 plus 1, 2 power. So this is 2 u of 2. 3 into 4, 12. 12 is the answer. Take it. Convolution in time domain. So let's say x1 of n convolution with x2 of n. This is going to give you x1 of z multiplied with x2 of z with ROC is R1 intersection R2. That's what we are going to get. Let's take one example. A power n u of n convolution with a power n u of n. This is what we have to calculate. Okay. So for this, we know that it is going to be n plus 1 a power n u of n. N plus 1 a power n u of n. Whether it is going to give you correct answer or not, let's see. So if I find the Z transform for this, this is going to be 1 by 1 minus a z inverse multiplied with 1 by 1 minus a z inverse. So that is equal to 1 by 1 minus a z inverse whole square. For this one, what is the inverse Z transform? We know that n plus 1 a power n u of n. This is what the inverse Z transform. Clear? Take it. Let's take this question. Question number 5. X of z is given as z power 4 plus z square minus 2z plus 2 minus 3z power minus 4. If h of n is equal to delta n minus 3, then find small y of 4, y of 2, y of 7, y of 7. These things we have to calculate. So I told you y is nothing but x of n convolution with h of n. So here y of n is nothing but x of n convolution with h of n. But in the Z transform will give you y of z is equal to x of z into h of z. Now from this, can you tell me what is h of z? H of z is nothing but z power minus 3. Z power minus 3. That's what we have to substitute here. So z power 4 plus z square minus 2z plus 2 minus 3z power minus 4 multiplied with z power minus 3. Then what we are going to get? Z plus z power minus 1 minus 2z power minus 2 plus 2z power minus 3 minus 3z power minus 7. So this is what y of z. And you might remember, for a finite duration signal, how we have to write the Z transform. This is the way we have to write the Z transform. And I told you, negative values of n is going to give you positive powers of z, and positive values of n is going to give you negative powers of z. So based on that, the coefficient of z is nothing but y of minus 1. So here the coefficient is nothing but y of minus 1. The coefficient of z power minus 1 is nothing but y of 1. The coefficient of z power minus 2 is nothing but y of 2. The coefficient of z power minus 3 is nothing but y of 3. The coefficient of z power minus 7 is nothing but y of 7. So these are the things what we know. Now we can directly say whatever the value they are asking. So first let's say y of 4, which is not there. So y of 4 is equal to 0. Next, y of 2. Y of 2 is here. Y of 2 is equal to minus 2. What is y of 7? Minus 3. Y of 7 is equal to minus 3. So these are the answers. Clear? Check it. Y of n is equal to g of n convolution with h of n, where g of n is causal. G of n is causal. H of n is equal to 1 by 2 whole power n u of n. If y of 0, small y of 0 is equal to 1, small y of 1 is equal to 1 by 2, then g of 1 is take this question. Options 0, 1, 1 by 2, 2 by 3. Okay. Listen. So they want to calculate finally g of 1, and they have given some values y of 0, y of 1. So that means there may be some relation between g of 1, y of 0, y of 1. So let's see what is that relation we have to see. Given what they have given, y of n is equal to g of n convolution with h of n. So if I take Z transform on both sides, y of z is equal to g of z multiplied with h of z, and they have given h of n. So what is h of n they have given? 1 by 2 whole power n u of n. So from this, can you calculate what is h of z? This is 1 by 1 minus 1 by 2 z inverse. This is what h of z. Substitute here. So that implies y of z is equal to g of z divided by 1 minus 1 by 2 z inverse. If I do the cross multiplication, that implies what is g of z is equal to, which is y of z minus 1 by 2 y of z into z inverse. Z inverse. So this is what g of z having a relation with y of z. So from this, if I take inverse z transform on both sides. So what is g of n? G of n is equal to, so y of z having inverse z transform, y of n minus 1 by 2 y of exponential multiplication in the z domain. That means in the time domain it is a time shifting. So y of n minus 1. So this is the relation between g of n and y of n. Now we have to see what is g of 1. That means at n is equal to 1, g of 1 is equal to y of 1 minus 1 by 2 y of minus 1. Sorry, 0. Y of 0. And these values are known. Y of 1 is equal to 1 by 2, y of 0 is equal to 1. So what is g of 1? Y of 1, 1 by 2 minus 1 by 2 into 1. That is nothing but 0. So you can get the value 0. Clear? Take it. Unilateral Z-transform. Till now we have seen bilateral. So what is unilateral Z-transform? X of Z is equal to summation n is equal to 0 to infinity x of n z power minus n. So we don't consider x of n for n less than or equal to minus 1. So n less than 0 we can say directly, n less than 0, that is n less than or equal to minus 1. For them we don't have to consider. So based on this we don't have any question, but still let's see. Suppose if it is given u of n minus or n plus 2, then where it is existing? Minus 2, minus 1, 0, 1, 2 and so on. So these portions we don't have to consider. If I don't consider this one, then it is the same as u of n. Then for u of n, what is unilateral Z-transform? UZT is nothing but 1 by 1 minus Z inverse. Here we don't talk about the ROC concept again. Okay. Next, suppose if it is given like this, x of n is equal to 2, 4, 6. Here is the arrow. So we don't consider the negative portion. Then what is x of z? 4 plus 6 z inverse. 4 plus 6 z inverse. Clear? Take it. We don't consider x of n for n less than 0. So these are little bit different than the continuous time case. Let's see how different they are. Initial value. Initial value means, suppose if I know x of n, small x of n, in that if I take n is equal to 0, that is called as initial value. Then this can be calculated from the Z transform also. Z tends to infinity x of z only. So there is no factor z here. That is the one thing which is different. Next, final value. To calculate final value, the formula is x of infinity limit, not z tends to 0 actually, z tends to 1, 1 minus z inverse x of z. 1 minus z inverse x of z. So this is what the formula we have to use. Clear? So here also we are having conditions. That means if the conditions are met, then only we can apply initial value theorem and final value theorem. If the conditions are not meeting, then we have to go for the original method. That means we have to calculate x of n. From that x of n, we have to substitute n is equal to 0, n is equal to infinity. These are the things we have to do. So what are the conditions? which are similar to that of continuous time case conditions. Initial value theorem, final value theorem. So both the theorems are applicable only for causal signals. So applicable only for causal signals. Final value theorem is also same, applicable only for causal signals. Next, second point. X of z must be proper fraction. Must be proper fraction. What do you mean by that? So degree of denominator is greater than degree of numerator. So here if I take like this, 1 by 1 minus z inverse. Is it a proper fraction? Yes, definitely it is a proper fraction, because in the Z transform, inverse is the standard form. So if Z inverse is there, that is the standard form. Clear? So if it is in the standard form, yes, the degree means how many poles we are having? One pole, 0 zeros. So number of poles more than the number of zeros. So it is a proper fraction. So these kind of things you have to say. Okay. Next. There should not be any pole outside outside the unit circle. And there should not be any complex pole on unit circle. These two conditions has to be met. So similar to that of continuous time case only, but it is a unit circle we have to take as a reference. Okay, take it. Find initial and final values of x of z is equal to 1 plus z inverse by 1 minus 0.25 z inverse, z power minus 2, sorry. Okay. So I want to apply initial value theorem, final value theorem to calculate the initial value and final value for this signal. So whether it is satisfying the conditions or not, we have to check that. So let's see whether it is satisfying or not. First, causal we don't know, because that information is not there. So only one thing we can check, whether it is a proper fraction or not. Yes. So it is a proper fraction because we are having more number of poles than the zeros. So proper fraction. Proper fraction. So we can apply initial value theorem. Initial value theorem. So what is x of 0 limit z tends to infinity x of z, that is limit z tends to infinity x of z, that is 1 plus Z inverse by 1 minus 0.25 Z inverse. So if I directly substitute Z inverse, that is infinity value, this value 0, this value 0, finally 1 we are going to get. That is the initial value. Next, what are the poles here? Poles is equal to, actually Z square is equal to 0.25. 0.25. That implies Z is equal to plus or minus 0.5, which are inside the unit circle. Plus 0.5 minus 0.5, both are inside the unit circle. Inside the unit circle. Then we can apply final value theorem. That implies final value theorem can be applied. So what is x of infinity? That is limit z tends to 1, 1 minus z inverse x of z. That is limit z tends to 1, 1 minus z inverse into 1 plus z inverse by 1 minus 0.25 z inverse. So there is no calculating term, so we can directly substitute z is equal to 1. This value will become 0, so entire value will become 0. 0 is the final value. Clear? Take it. 8. If x of z is equal to 0.5 by 1 minus 2 z inverse. If ROC includes unit circle, then small x of 0 is equal to dash. Options 0.5, 1, 0, minus 1. So to calculate x of 0, initial value theorem. So let's say if I apply initial value theorem, small x of 0 is equal to limit z tends to infinity 0.5 by 1 minus 2 z inverse. So directly we are going to get 0.5, which is a wrong answer. Why it is a wrong answer? So you might ask, sir, we are having proper fraction only. Proper fraction means we can apply the initial value theorem. So why we are getting a wrong answer? Okay, proper fraction is okay, I can agree with that. But is it satisfying the first condition? That means causality. First we have to check that. So let's see. For that they have given some information. ROC includes unit circle. Let's say, first of all, what is the pole here? What is the pole? Pole is equal to z is equal to 2. Pole is equal to z is equal to 2. So z is equal to 2 means, let's say if I take z is equal to 2, correspondingly this is the circle. Let's say correspondingly this is the circle. Now for this circle we are having two ROCs, maybe inside ROC, maybe outside ROC. But they have said ROC includes unit circle. Then which ROC we have to say take? That is inside ROC. Why? That must include unit circle. That should include unit circle. So to include unit circle, ROC must be inside the circle. This is the ROC we have to consider. So with this ROC, we can conclude that x of n is not a causal, it is a non-causal, or we can say left-sided signal. So x of n is non-causal. That is left-sided signal. Left-sided signal. So if it the left sided signal, then first we cannot apply the initial value theorem. So initial value theorem is not applicable. On this case we can say applicable, not applicable. Then what we can do, directly we can calculate x of n. Because it is a left side signal, we have to change the sign, that is minus 0.5 into 2 power n u of minus n minus 1. Then what is x of 0? X of 0 is equal to minus 0.5 2 power 0 u of minus 1. What is u of minus 1 value? That is 0. So finally we are going to get 0. So answer is